All right, section 6, communicative and associative properties. Let's go. All right, nothing new in vocabulary, just a couple of concepts we need to learn. So properties. So communicative property, the order in which you add and multiply numbers does not change their sum or result. So for any numbers a and b, a plus b equals b plus a. Also, within multiplication, a times b is equal to b times a. So I can flip the number, or the order I do them in when it says multiplying, and only addition. So 6 plus 5 is 11, or 5 plus 6 is 11, and 6 plus 5 is 11. 3 times 2 is 6, so is 6 times 3. Now, this does not superinvent or go before PEMDAS. It's just when you're in the multiplicate or addition, it doesn't matter which direction you or what order they're in. And this is going to come into play in some algebra things in a little bit. Okay, so the associative property, this is the other thing we're doing today. When you group 3 or more numbers, or the way you group 3 or more numbers when adding or multiplying does not change their sum or product. So if I have a plus b, and then in parentheses plus c, is the same as if I group a plus and then parentheses b plus c. Same thing in multiplying, I can group a and b and do those first, or I can do b and c. So what that looks like in numbers is 2 plus 4 is 6, plus 6 is 12, or 4 plus 6 is 10, plus 2 is also 12. So that comes out to 12 equals 12. Over here I can multiply 15. 3 times 5 equals 15. 15 times 4 equals 60, I think. Yep. Or I can go 3 times 4 is 20, times 3, 20 times 3 is also 60. So those both come out to true statements. All right, so let's see what this looks like in a real world thing. There was a page in the example 1 in page 35. I probably should have taken a picture of it. Find the distance between the city of Lakewood and Fort McAllison and 5 points. So there's 3 different cities. Explain how the communicative property makes calculating the answer unnecessary. So in this picture, I'm assuming there was the distance between these 2 cities and Oakland City to West End to Garnett are all 1.5, 1.1 with an n 0.4. So these would be like this city to this city, this city to this city, this city to this city. So if we had these all on a line like this, this would be Lakewood, this would be Oakland City, this would be West End, this would be Garnett. So there'd be the 4 things. This is 1.1, 1.5, 1.5, and 0.4. Something like that. So if we add them all together, the order in which we add them doesn't matter because it's commutative. So commutative property of addition. So I can group them together and add them. So I can add the like ones together here that are 1.5 is just doubling it. So I add those together. Those turn into 1.5, which gives me a third 1.5, which goes to 4.5. So the distance is 4.5 miles. So that's kind of nice when you got it, this kind of thing. So calculating the answer is actually unnecessary because the root is the opposite of example 1. Again, I don't have that one there, but you can see how commutative and associative can be used to add things together. Check your progress. Since we don't have it, we're going to skip it. All right, use multiplicative properties. Evaluate 2 times 8 times 5 times 4 using properties of numbers. Name the property used on each step. Okay, so you can rearrange these and group them together and make mental calculations easier. So I can reorder these 2 times 5 and 8 times 7. So they kind of moved them around there. Communicative property of multiplication. I like how they shorten this instead of writing it all out. Then I can associative by grouping them. So 2 times 5 is 10. 10 times 56, or 8 times 7 is 56. And now we can multiply 10 times 56 is going to go 560. Also, we can do that mentally a little easier. All right, pause this one, give it a shot. All right, so what they want us to do is reorder these. So I could go 3 times 3 times 4 times 5, group them. 3 times 3 is 9, 4 times 5 is 20, 9 times 20 would be 18, and 0. All right, so we're going to talk about these. This is a lot of them, but we've kind of already said some of them. So this is kind of all the things in the last two things in kind of one shot. So communicative. So it doesn't matter what order, B plus A, and A equals A plus B equals B plus A. And then multiplication, A times B is B times A. That was yesterday. Associative, it doesn't matter how I group them. It will come out the same in addition and in multiplication. So it doesn't matter how I group it. Identity of addition, if you add it to 0, if you add 0, it'll come out as the original. In multiplication, if you times it by 1, it'll come out as the original number. There's nothing for 0. Multiplying by 0 comes out 0. You can distribute by doing this number. Same thing, going backwards, doesn't matter. And then substituting, if B times A, then it may be substituted for B. So that was just substituting things in. All right, write and simplify the expression. So writing an expression and then working on it. So use the expression 3 times the sum of 3x and 2y added to 5 times the sum of x and 4y. Sounds like a lot. We're just going to break it down one piece at a time. Write an algebraic expression for the verbal expression. So the first one, in 3 times the sum of 3x. 3 times the sum of 3x and 2y. So it's going to be the sum of the addition. So 3 times the sum of 3x and 2y. I'd say these would actually go in parentheses. And we'd have a 3 out front of that. And then the sum is going to turn into a plus. And then added to would be a plus. And then 5 times the sum of this one and this one would be an addition, and then a 5 outside of that. So we're going to let x and y represent each number because, you know, they're already in there as x and y. So the equation, 3 times 3x, the sum of 3x plus 2y would be a sum of 3x and 2y times 3. And then the sum of x and 4y times 5. So there would be my answer to that. Do they want me to simplify it? Nope. Oh yeah, simplify the expression and indicate the properties used. Part 2. So I would distribute them out. Distribute, distribute turns into these two. Distribute, distribute turns into these two. Now we're going to multiply those out. 3 times 3 is 9, keep the x. 3 times 2 is y, keep the y. 5 times x is 5x. 5 times 4 is 20, keep the y. Communicative property means I can reorder them. So all we did was put the y's and the x's by each other. So now I can easily see if there are like terms. So associative property, I can group them however I want. Groupative property of addition. Now they're going to want us to distribute them. So pull the x out, pull the y out, add them together, which would come out to 9 plus 4 is 14, or 9 plus 5 is 14, keep the x. 6 plus 20 is 26, keep the y. And then that would be my answer. Pause this, give it a shot. All right, so we're going to go 5 times the sum of 2x and 3y. So I'm going to do that one first. So 5 times the sum of 2x and 3y. So I put that in parentheses, 2x plus 3y. Increased, so that looks like a plus. So 2 times the sum of x and 6y. X plus 6y. From here, I'm going to just, is that as far as they want me to go? Looks like it. Okay, so that was the hard part. Now we get to simplify. Simplify that expression. Oh man. I'm going to bounce back here so I can see it. So 5 times 2x is going to be 10x. 5 times 3y is going to be 15y, and it's plus plus, stays addition. 2 times x, and then 2 times 6y, so 12y would be addition. We could reorder this. If you can skip that step, that's totally okay. I'm just going to add them together. So 10 and 2 is going to be 12x's. 15 plus 12 is 27y's. See, 20 and 7. Let's see what that comes out to over here. 12x plus 27y.